What is up, stats nerds? I'm Professor Charlie Collins. Welcome to another feature of Current Mode, where we aren't mean, we're just average. Today we're talking about logistic regression. Logistic regression is a statistical method used to analyze relationships between a categorical dependent variable on the one hand and one or more independent variables. In this discussion, we'll focus on how to conceptualize logistic regression, how it applies in practice, and how to interpret the results. And we'll finish up by contrasting it with linear regression. In logistic regression, the dependent variable, also called the outcome variable, is binary, meaning it can only take one of two possible values, usually coded as 0 or 1. Usually we think about this as the probability of an event occurring. Right? 0 means it doesn't occur, 1 means it does occur. The independent variables, also called the predictors or covariates, can be either continuous or categorical. The statistical output in linear regression is interpreted as the probability of a dependent variable taking the value of 1, or an event occurring, given the values of the independent variable. Now, to apply logistic regression in practice, we need to have a data set that includes a binary dependent variable and one or more independent variables. We can use this data set to estimate the coefficients of the independent variables and to make predictors about the probability of the dependent variable taking a value of 1, or an event occurring, given the values of the independent variables. Now, the coefficients of independent variables in a logistic regression can be interpreted as the change in the probability of the dependent variable taking a value of 1 for a 1-unit increase in the corresponding independent variable, holding all independent variables constant. For example, if the coefficient of a binary independent variable is 0.5, this means that a 1-unit increase in the independent variable corresponds to a 50% increase in the probability of the dependent variable taking the value of 1. Or, to say that a different way, the probability of an event occurring, right, given that the independent variable is 0.5. So in other words, logistic regression is interpreted as the probability of a positive outcome given the predictor values. So for example, if the logistic regression predicts a probability of, let's say 0.8, right, not 0.5, but 0.8, for a given set of predictor values, this means that the model estimates an 80% chance of the positive outcome occurring given those predictor values. So let's talk about some quick examples here, right? So one of the most classic examples of logistic regression is the prediction of the presence or absence of a disease based on the values of one or more diagnostic tests, right? Also known as independent variables. In this case, the dependent variable is binary, presence or absence of the disease, right? 1 or 0. And the independent variables are the results of the diagnostic tests. Okay, and so the logistic regression model estimates the probability of the disease given the test results. And it can be used to make diagnostic decisions or to identify risk factors for the disease. Another example is the prediction of voting for the Democratic Party based on the values of one or more factors, right? So this could be like party affiliation, education level of household debt, so on and so forth. In this case, the dependent variable is the binary, vote Democrat or not, and the logistic regression model estimates the probability of voting for the Democratic Party given various political factors. So this model can be used by, let's say, party leaders, for example, to assess the likelihood that a voter would support the party or not, and how to monitor that progress. So let's contrast logistic regression to linear regression. So logistic regression is similar to linear regression, but there are some really important differences between these two methods. The first main difference between logistic regression and linear regression is the type of dependent variable that each method is used in the model. And so for linear regression, in linear regression, we use a continuous dependent variable, whereas logistic regression uses a dependent variable that is binary. Another big difference between linear and logistic regression is the type of output that each model produces. So in linear regression, it produces a continuous output, which represents the predicted value of the dependent variable given the values of the independent variables. Logistic regression, on the other hand, produces a probability output. And what that means is that it represents the estimated probability of a dependent variable taking the value of 1, or again, an event occurring, given the values of the independent variables. So to conclude, logistic regression is a powerful statistical method for analyzing the relationships between a binary dependent variable and one or more independent variables. It enables us to estimate the probability of the dependent variable taking the value of 1, given the values of various independent variables. It can also be used for a wide variety of applications, from disease diagnosis to assessment of voting patterns. And understanding how to conceptualize, apply, and interpret logistic regression is a valuable skill for data scientists, analysts, and researchers really across the social sciences. So I want to leave you with a thought experiment. Think about your likelihood to travel internationally this summer as a binary dependent variable, where 1 equals traveling and 0 equals not traveling. Now think about some independent variables that might predict whether or not you will travel this coming summer. This could be something as mundane as the cost of flights, or really as critical as international political tensions. Now, come up with a list of 5 different factors that might improve or decrease your probability of traveling internationally this summer. Once you got those, you're one step closer to being a statistician and really understanding logistic regression. Thanks for watching Current Mode. I'll catch you next time.